Good evening, everyone. Welcome to this session on AI Masterclass using MATLAB. I warmly welcome you to the session. First, I would like to thank you for your participation and thanks for coming today. And thank you for your commitments towards learning. Today's session is about image processing using MATLAB. Before we go into the session, first I would like to give you a short introduction about Pantech and about me. Pantech was started in the year 2004. We manufacture embedded motherboards like microcontroller boards, DSP boards, and FPGA boards. We do also manufacture electronics and electrical lab equipments. We also manufacture sensor interfaces like EEG headset and add-on boards. If you want to know more about our products and services, you could log on to our website pantechsolutions.net. About me, my name is Jeevarajan. I completed my BE in the year 2002 from Government College of Engineering, Burgu, and my Masters in College of Engineering, Guindy from the year 2004. Basically from applied electronics, I used to work on microcontrollers, DSPs, and FPGAs. I am responsible for the research and development team in Pantech. So over the period of time from 2004 to 2020, I have around 16 years of experience on solving various algorithms on image processing, machine learning, and deep learning. So this session is about sharing my knowledge to you. So if you have any questions, you could post it on the Excel sheet which we have provided. So we have sent the Excel sheet through email today. So you could log on to the email and you could check it out for the questions you have posted yesterday on that form. And if you want to connect me, connect me on LinkedIn, I'm happy to connect and happy to help. I have provided my link in the description box. Just send me a connection request. We will connect and learn together. So today's session is about image processing using MATLAB. So in this session, we are going to cover up how to read and store images. That in this we'll be going through various file formats of image, like what is a BMP format, what is a PNG format, and TIFF format, and how to read the format, and how to resize the image, and how to rewrite the image, rewrite and store the image in the folder. That we'll be covering up in the session. And then we'll be going through how to convert a color image to a grayscale image and a binary image. So that we'll be covering up. And how to do a mathematical operations in image, like image addition, how to perform image addition, image multiplication, and image complement, and image division. So that will be covering up in mathematical operations in image. And channel separation, we'll be covering up how to split the channels in a color image. So when you process color image, you have to split the planes and you have to process. That will be going through on channel separation. And edge detection, we'll be applying different edge detection algorithm, like Canny algorithm, Sobel algorithm, or Prewitt algorithm on image, and how to display the edge detection images. That will be going through. And noise filtering and noise unfiltering, we'll be going through how to add different kind of noise to image, how to add a salt and pepper noise, and how to add Gaussian noise to the image, and how to filter the noise by using a median filter or a Wiener filter. That will be going through in noise and filtering. And thresholding and image segmentation, in this example, we'll be covering up how to do a manual threshold and how to perform segmentation using manual threshold. That will be covering up, and how to count the number of objects in an image using morphological operations. That will be covering up in boundary labeling and counting. And histogram equalization, we'll be covering up contrast enhancement, how to enhance the image, do contrast enhancement on image by using histogram equalization. So these are the topics which we'll be covering up today. So once you complete the session, you'll be familiar with the basic image processing, how to do morphological operations, and how to read the image, and how to resize the image, and how to convert the image to various formats. This is a practical session. First I will explain the code on the slide, then we can go to MATLAB and we can practice. Okay. So the first thing is how to read and store image. First example is how to read and store image. So in this example, like I have used a command called imread. Imread is a command which is used to read image. So whatever the file format is, like the cameraman.tiff is stored in the MATLAB root folder. Like TIFF stands for tagged image file format. Okay? There are different file formats. PMP is a file format, the bitmap file format, and JPG is a file format. It's a compressed file format, JPEG file format, and PNG for portable network graphics, and PGM for portable gray map, and DCM for like DICOM image file format. That is for medical imaging. Okay, so these are all different file formats. So when you give imread, so MATLAB will read the image and it will convert that to a matrix. So it will give you the pixel information. Like matrix will have elements. So each element is called pixels or pils that contains the information about the image. So if you read a grayscale image, you will get a single matrix. If you read a color image, you will get a 3 matrix. You will get a matrix for red, matrix for green, and matrix for blue. Okay. So that's the advantage of MATLAB. So no need to worry about the file formats, whether it is a TIFF or whether it is a PNG or whether it is a PGM. You just use this command. It will convert that to a matrix. Whereas in C language, like you have to know the header and the photo structure of the image to decode that to a matrix form. If you want to read the pixel in image without knowing the structure, without knowing the header and the photo information of the file formats, you cannot read and you cannot convert. So that's the advantage of MATLAB. So imshow is a command which is used to display, and impixelinfo is used as a command which is used to view the pixel information. So once you move the mouse over the image, you could view the pixels by using this command. Okay. Imwrite is a command which is used to store the image in file form, whatever the file format you want. If you read a TIFF image and if you want to store that in as a PNG file format, you could convert. You just use this command imwrite and mention the file name with the extension. Okay, test.png. PNG is a portable network graphics. Whatever the file format you want, you could use that. And DICOM info is used to get the information about the DCM file. DCM is the file format which is used for medical imaging. Usually the other images like the TIFF format and the PNG format will be stored in a 8-bit format. Okay, every pixel will be represented in terms of 8-bit, whereas this DCM file format will be represented in terms of 16 bits. Okay, the pixel will be represented in 16 bits of data. So DICOM read will read the image, and imshow is the command which is used to display the image. Okay, so this is a program. So imread to read the image, imshow for display the image, and impixelinfo to view the pixel information about the image, and imwrite is used to write the image to store the image, and DICOM info is used to get the information about the DCM file, and DICOM read will read the file, and imshow is the command which is used to display. Okay, I will open MATLAB. Let us practice the same code on MATLAB. So I have created a folder called day2 on my desktop. Okay, so I'm copying this folder. The first thing you have to do is to copy this folder and change the path. So I'm copying this folder and I'm going to change the directory cd Control V. Okay, I have changed the directory cd single quotes. I have pasted the folder. Else you could also straightly go to this path and you could right click and you could paste it here and enter and press enter. This is to change the folder. So I'm going to type edit to open an editor window. So just to open the editor window, okay, I'm going to type a CLC clear for workspace clear. I'm going to read image. First, I'm going to read a cameraman.image, cameraman.tiff. Okay, just I have read the image. So if I want to display this image, imshow of it. Okay, save the image, example1. So if you run the program, so this is the image. Okay, just type who's in the command window. You will get the size. It contains of 256 rows. The matrix contains of 256 rows and 256 columns. A is a matrix. Okay, A is a matrix which contains the size of the matrix is 256 rows and 256 columns. Since it's a grayscale image, you got only one matrix. So total is 65536. And if you click this workspace on A, you will get the matrix. Okay? You will get the matrix. These are all the pixel values. Okay? If you want to visualize this pixel values, you could type IM pixel info, IM pixel info, save the program and run the program. So when I move the cursor, like it will show you the location of the pixel as well as the rows and columns of the pixel and the value, like 173 is the 173, 172 is the pixel value, intensity value. Okay, it will be 8-bit. So the value will range from 0 to 255 if it is a grayscale image. Now I'm going to read a color image. So rows.png. Okay, rows.png. Hit the run button. So if you check now, like it has 3 pixels. Each location has 3 pixels. For red, you get 1 pixel, and for green, 1 pixel, and for blue, 1 pixel. Only the combination of this 3 pixel will give you the color red, green, and blue. Okay, RGB image. So if you check who's now, this image has 427 rows and 527 columns with 3 planes. Okay, so it means it has 3 matrices. For red, you get a matrix, for green and for blue. Okay. So if you want to resize this image, you could just resize b equal to, I'm going to convert this image to a size of 256 rows and 256 columns. This I'm mentioning this is subplot of 1, 2, 1. 1 row and 2 columns. The first thing is the first image, subplot of 1, 2, 2. Okay, in show of B. Save the program and run the program. So hit the run button. Okay. So this is the original image and this is the resized image of 256 rows and 256 columns. If you type whose, so B contains of 256 rows and 256 columns and 3. Okay, whereas the input image contains of 427 rows and 527 columns into 3. Okay. So to read the DICOM images, I'm just typing help DICOM info in the command window. Like I got a sample here. Copy this sample. I'm creating a new program. LC clear. Okay. So this image is in the MATLAB root path. So DICOM info. So if you the next save the program, example2. So if just keep a breakpoint and click and run this button. Okay. If you check info, this is info is a structure, like it will have the information about the DICOM image, like where is the file name, what is the file name, and where it is located. It is located, the file name, and the file modified date is on 18th December 2000. Okay, and the time and the format, DICOM format, and the width and the height of the image. This is the bit depth. It contains of 16 bit per pixel. Okay, so it's a grayscale image. And the other information like encoding, everything. Okay, so you could read this as help. You could just type help DICOM read. So this will give you a format. You copy this format. Okay, save the program and run the program. So if you want to align this, like you could align the indent here. So this is the image, but it is a 16-bit. Okay, so you have to mention this square bracket. So if you check now, you got the image. Okay. This program is used to read the DICOM images. DICOM is for medical imaging. So info, DICOM info to read, DCM is a file format. DICOM read is to read the image, and IMSHO is the command which is used for display. So I am right. So I am right is a command like if you want to write the image, okay, if you want to store the image, I am right of B, I'm going to store this image B to test.bmp. So I'm going to convert that to a BMP format. So run the program. And if you check in the folder, current working folder, a new image has been created of size 256 rows and 256 columns. The width and height of the image has been displayed, 256 rows and 256 columns. And this is the image. Okay. So far we have covered up how to read the image, how to resize the image, and how to store the image, and how to view the pixel, like IM pixel info. And subplot is used to plot two images, to display two images on a single figure. Okay, this is the row and this is the column. One denotes that it is going to have one row, and two denotes that it is going to have two columns, and this is the one denotes the first image and two denotes the second image. Okay, and DICOM image, to read the DICOM images, DICOM info, DICOM read, and IMSHO. So these are the commands. If you want to read a bulk image, like if you want to read a folder if you want to read images which is stored in a folder, for example, in this folder I have a folder called data where I have 5 images. Okay, in that case you could use image data store. You just type help image data store, you will get a command. Okay, so you copy this command because it involves capitalization, and CLC clear, and I'm going to read the folder called data. Okay. So save the program as example3 and run the program. Hit the run button. So if you check this IMDS, okay, IMDS contains of it contains of all the files, like all the file path. Okay, so these are all the files which was file path of the images. And if you want to read the image, just type help image data store. Okay, copy this code. Figure of I am sure of A. Okay, I am reading the image. It contains of 5 images. The folder contains of 5 images. So if you check now, save the program and hit the run button. So A will have the first image. This is the first image. Okay, so hit the continue button. So you will get the second image and the third image and the fourth image. Right. So whenever you go for a deep learning or machine learning, whenever you want to read more number of images for training, so you could use this command called image data store. Image data store, and this is the folder where you want to read the images. Okay, all those files will be stored in IMDS, image data store. It won't read, the information will be stored in the, it is a structure. So if you move the mouse to this point, like, so it contains of how many files. So this will give you the number of files. Okay, number of images, So if you check here, like the number of images is 5. Okay, so I'm going to run a for loop to read all the 5 images, and I'm going to display. Read image is used to read the first image. When I equal to 1, it will read the first image. When I equal to 2, it will read the second image, and it will display. Okay, so this is the program to read an image from a folder. This is usually used for deep learning and machine learning, where you have to read a lot of images from the folder. So the next example is on types of images. How to read a RGB image and how to convert that to a grayscale image and how to convert that to a binary form. Okay. So I'm opening a new file, CLC for clear screen, clear for variable clear. Okay. I'm going to read image rows.png. We have already have a image in the folder called rows.png. Okay. PNG stands for portable network graphics. This I'm going to convert that to gray, RGB to grays. That converts to a gray. Okay. Is equal to IM to BW stands for image to binary. Convert that grayscale to a binary image. Binary will contains the pixel information will be only ones and zeros. So I'm going to plot this image. I'm going to have 1 row and 3 columns. This is the first image. Show of A. Okay. And I'm going to copy this one. This is B and this is C. I'm going to change this 2 and 3. Okay. Example 4. It's very simple. So read an image, RGB to gray converts that to a grayscale, and IM to BW converts that to a binary form. Subplot is used for display. So if you check this, if you run the code now, okay, so if you run this code now, okay, I think it was in previous program. Let me CLC, I put a breakpoint here. So close all the programs, close all the figures which was open in the previous program. Okay. So this is a color image, this is the grayscale image, and this is the binary image. So if you want to view the pixel information, you just type in pixel info. Okay. So now if you check now, so this contains, so RGB will have red, green, and blue at the bottom. Okay, here, okay, and this is grayscale image. It will have only 1 pixels, whereas this will have 3 pixels for each location, and this will have only 1 pixel, but the pixel value will be only zeros and ones. It's a binary image. So in this code, we are reading an image, convert that to a grayscale image, convert that to a binary, and just we have displayed the image. Okay. So first we have in the first program we have read the image, resize the image, and write the image, store the image. In the second program, we have read the DICOM info image, and we have read the image and display the image for digital imaging for communication for medical imaging. Okay, DICOM stands for medical imaging images, and in example 3, we have used image data store to read like if you want to read bulk images like 100 images or 10 images from the folder, then you could use image data store. So image data store, this is the folder name, and get the total number of files. Okay, total number of files from this imds.files, and run a for loop. Read the first image, open a new figure, and imshow is used for display the image. Okay. In example 4, we have read the image, convert that to a grayscale image, convert that to a binary image. Okay. So we will go for the next one. Mathematical operations in image. How to do an image addition, how to do an image subtraction, and how to do image complement and image multiplication. Right. So my advice is to always use help commands to navigate, because sometimes MATLAB involves capitalization. You have to put the syntax in proper capitalization. For example, if you check help image data store, D should be on caps. Okay, D should be on caps. So always use help command. So for mathematical operations image, I'm going to read, clear, close all. Okay, read image. I'm going to read the image cameraman dot. Just add b equal to add of a comma 50. Let us check subplot of 1 comma 2 comma 1 and m show of a. Okay. You copy this one, paste it here, change that to 2, and this is b. Save the program. Example 5. Example 5. Breakpoint is used to stop the execution of the program. You could keep a breakpoint here, and if you could run the program just for debugging or for visualization. Okay, so like if you check now, this is the image and this is the intensity. We have added 50 to the pixels. So if you check the value of A and B, okay, this is A. If you open, you get a matrix here. B, this is B. So if you check A, the value is 156 for the pixel 1 comma 1, and 1 comma 2 is 159. And if you check for B, it is 206 and 209. 50 has been added to the pixels. Okay. So when you add a pixel, it changes the intensity. So the contrast will be at like the intensity the contrast will be enhanced by intensity adjustment. Okay. This is a simple example for image addition. The same thing you could done for image subtraction also. Like instead of I am add, just put I am subtract. That will decrease the value. Okay. Run the program and check. This will decrease the value. I am add and I am subtract. I am complement. You just add I am complement. Like I am complement works better on I am complement of A for the binary image. Okay, whenever you do like so, I am converting this to a binary image just for an understanding. Okay, so I do complement on binary image. So this is the input image. This is the complement image. Zeros will be converted to 1 and 1 will be converted to 0. Whenever you do some morphological operations, and if you want to do like I am complement will be used to simplify, to make things simplified. Okay, so you just type help I am add in the command window. You could also add two different type of images. So you have I am absolute difference, I am complement, I am divide, I am linear combination, like I am multiply. You could choose this image and you could choose this one and right click, go for evaluate selection. So this will run the program and you could see the output here. Okay, you could use help command and you could go through the coding, select the commands, right click and evaluate selection. So that will run the coding. So you could analyze those things like ijk. So the value of ijk is here on the workspace. Okay, so you could analyze. Similarly for like division, you could do like image addition or image multiplication, whatever you want. Like there are sample codes there. Division, this is for division. Right click, go for evaluate selection. Okay, this is division. This is the input image and this is the image which you got after I am divide. Okay. So that's all about mathematical operations on an image. Like we have gone through image addition, image subtraction, image complement and I am multiply. There are also other like IM linear combination is there. You could go through the help command on MATLAB. Okay. The next example is on color channel separation. Okay. So this is usually done with a color image. Normally, color images will have three matrices. You will have a red matrix, green matrix, and a blue matrix. So you when you process color image processing, you have to split those channels and you have to process. Then you will later on you will be combining those channels. If you in this example, I will explain you the code in the presentation now. Imread is a command which is used to read the image, and imsplit is a command which will split the planes. So this command is available only after the 2019 version of MATLAB. Imsplit. I'll also show you the command, like if you use the older versions, I will tell you the command what to use for imsplit, okay, or GB. That will give you will split the channel to red, green, and blue. So if you this is to like you have to store only the red component. You make the green and the blue component as 0. So to visualize the red component of the image, if you want to visualize the green component, make the red and the blue component as 0. So red is first and green is second and blue is third. Okay. So if you want to visualize the blue component, you make the red and green as 0. Okay. So let us go through the program. So I'm typing edit in the command window. So I'm opening the program like CLC, clear, close all to close all the programs which was open in the previous program. I'm reading an image, rows.png. Okay. I'm reading image and like convert that to RGB equal to imsplit is the command to convert to red, green, and blue. Okay. So if I want to visualize the red component, so this is an empty array. I'm declaring that as an empty array first, and I'm going to convert this to red of, this is 1, allocate red, this is red, and this is the first plane. Okay, for first plane you have to load the red component, and for the second plane, the colon, it denotes that all rows and all columns. You cannot give a number here. If you give a number here, it will take only that pixel. So if you put colon, it means that it takes all rows and all columns. Okay. This is an empty array. To define an empty array, so if you visualize now like figure of show of red, save the program, example 6, and run the program. Okay, so it should be red, split of VA. Okay, so let me check now. This is the red component. Okay, this is the red component. So you should not declare this empty array. So red. For green, you load this component with green. You make 1 and 3 as 0. 1 and 3 as 0. Okay, 1 and 3 as 0. Now you copy this command, copy this line, figure of show of green. So this is the green component, this is the red component of the image, this is the green component. Similarly, if you want to visualize the blue component, copy this. I'm changing this to blue. Okay, blue. It should be 3, and this it should be 2, and this should be the blue component. Okay. Now run the program. Red, green, and blue. So you got the planes here. So if you're using the older version here, instead of IM split, like you have to write 3 codings, like for red, for R, you have to load A of colon comma 1. Okay. For green, you have to load A of colon comma 2. And for blue, you have to load that A of colon comma 3. Okay. Save the program and run the program. I have commented this line. So keep a breakpoint just to stop the execution. Okay, red, green, and blue. So I'll explain the code one more time. I have read the image. Okay, this is to split the planes. 1 stands for the red component, 2 stands for the green component, and 3 stands for the blue component. Colon comma colon denotes that it takes the all rows and all columns, because if you check the value of A has a size of 427 rows and 527 columns. Okay, so it will take all the 427 rows and 527 columns on the first plane. 427 rows, 527 columns, the second plane, and the third plane. Okay, you make the first component, you load the red component on the first plane and make the 2 and 3 as 0. That shows the red component. Okay, for green, load it on the second plane and you make the red and the blue component 0 to visualize green and to visualize blue. Okay, you make 3 as blue and the first and 2 as 0. That's a simple code to separate the channel separation. And the next example is on edge detection. Okay, how to read image and like how to apply edge detection. So CLC, clear, and close out. So the video will be available for 2 more days. So you could go through the video and like you could practice. If you think the video, if I'm going fast, you could go through the video and you could go step by step execution. And if you have any doubts, you just fill up the form. Okay. Rate of cameraman.tiff. So B equal to edge A comma canning. This will give you the canning edge detection. You can always type help edge to check how to use the function and what are all the like methods it will support. Like if you check here, it supports pre-width method, it supports Sobel method, it supports and zero cross method and canning method. Okay, so these are all the different type of edge detection techniques. Show of B. Okay. So if you check now, save the program as example 7. Okay, run the program. So this is the image and this is the edge direct image by using canning algorithm. If you want other algorithms, you just copy and paste. You just change that algorithm to Sobel. You just pass the variable. Okay, this it should be C and it should be D. You copy this one, you make this as 2, 2. It means 2 rows and 2 columns we are going to have. So totally we can load 4 images. This would be the third and the fourth image, D and C. Okay, save the program and run the program. Okay, so edge detection by canning like Sobel and pre-width. So I'll explain the code. Just read the image, apply canning algorithm, Sobel algorithm, pre-width algorithm. This is to plot, to subplot. Okay. So the next experiment is on thresholding. Noise and filtering. How to add noise and filter. Okay. So clear screen, clear for variable clear, and close all. I'm going to read the image. Read of cameraman.tiff. Okay, I have just read the image cameraman.tiff, and just type help IM noise in the command window. Help IM noise in the command window. It will you will get a syntax here to add a salt and pepper noise. Okay, and for applying filter, like C equal to MED filter 2 stands for median filter. It works for the salt and pepper noise. So for different noise, you need different filters. Like there is no common filter for for Gaussian noise. You need a Wiener filter, and for Poisson noise, like you need different filters. And there are like deep learning architecture for denoising, for image denoising, which will do the work for all type. But you have to train all type of noises. So it will identify the noise and it will apply the filter based on that. Okay, MED filter J comma. You have to mention the window size 3x3. So if you subplot of 1 comma 3 comma 1, I'm show of A, and you copy this code. Okay, I'm adding noise to this code. J is the noise added image. C is the median filter image. So this is example 8. So we have read the cameraman.tiff, add a noise to the image and apply the median filter. So once you run the program, this should be A. Okay. Okay, it looks like the salt and pepper has been thrown on the image. Okay, this filter, like what happens is, like if you check A is the input image. This is the pixel, okay, and J contains the noise added pixel. What happens in C is, for example, if you take the value 158, it takes the neighboring pixel 3x3. It takes the neighboring pixel value and it takes the median value for the neighboring pixel and it replaces the pixel value 2, 2 for 2, 2. For if you take 2, 2 for the location 2, 2, it takes the neighboring pixel 3x3. Okay, so totally 9 pixels are there, and it takes the median value for the 9 pixels and it replaces the pixel 2, 2. Similarly for 2, 3, it takes the neighboring pixel value, take a median value, and it replaces a pixel. This is how median filter works, and there are a lot of documentations available on Google, like how it works. Go through the documentation over there. Okay. So in this example, we have read the image, we have added noise to the image, and we have applied median filter to the image. If you want to do that for a color image, then you have to split that to red, green, and blue. Add noise for red, green, and blue separately, and again apply median filter for red, green, and blue separately. Then finally you have to combine this image. Okay, so that is to do for noise filtering for color images. So the next is on thresholding and image segmentation. Okay, so first I'll explain the code here. If in this code, like we have read an image, imhist is a command which is used to do a histogram, like just to plot the histogram. Like histogram is like the frequency of occurrence, and I'm show of A, like 100 is a manual threshold, is a threshold. So if the value is above 100, it will take us, it is 1. The value is below 100, then it will take us 0. Okay, so binarization based on threshold, and it applies the median filter on the binary image. It applies 5x5 image. It will be in double format. Convert that to an unsigned integer 8 format. So it's a binary format. So convert that to unsigned integer format, and you apply matrix multiplication. Like you fit the mask on the original image, you will get the segmented coins. Okay, so let's go to the program. I'm opening a program, CLC, okay, clear, close all. I'm going to read the image, coins.jpg. Okay, I have read the image, A equal to imread of coins.jpg, and like convert that to a binary. So to convert that to a binary, so I'm using a threshold. Okay, so this converts that to a binary. If you want to view the image, figure show of T. Example 9. So run the program. It's coins.png. Okay, so this is the input image figure. This is the input image, and this is the binary image. So in order to remove this, the noise, okay, these are all the noise present here. So to remove this noise, I'm going to apply a median filter. C equal to med filter to of B, comma, the mask, it takes a 5 cross 5 mask, it means 5 neighbors. Okay, and let us check figure of I'm sure C. Save the program and run the program. Okay, this is the output. This is the noise removed output. Input image, noise removed output. Okay, you have to convert. This is a binary, so convert that to an unsigned integer 8. U into 8 of C. Okay, so if you apply this, if you apply so E equal to D into A. So figure of I'm show of. So this is a mask. Okay, so we convert that mask to. So this is the segmented coin. Now the coin has been segmented. If you want to count the number of coins, then you could use a command called bw label here. Bw label of bw label of C. You have to check the value of C. Okay, and num will give you the number of coins. So if you check the num, it shows it has 10 coins over here. So 8, 9, 10. Okay, so the number of coins here is disp of num gives the number of coins. Save the program. So BW label is the boundary labeling of closed connected components. Okay, so it will count. For example, if you want to count the number of oranges in a tree or number of apples in a tree, have to do morphological operations, then you could use boundary labeling command to count the number of apples or oranges or coins. So here we have counted the number of coins. So num will give you the number of coins. So this is used to read a image manual threshold. The 100 is decided based on the histogram. Okay, you just apply IM hist of A and save the program and run the program. Like it will show you the histogram plot. Okay, if you check this histogram plot, the majority of the value, so 0 to 255 is the pixel range, and this is the occurrence. Like for example, if you take 50 has been occurred for around 600 times. Okay, if you check the value, pixel value of around 150, it has occurred of 600 times. The majority comes around 80 occurred 1600 times. So these are the pixel values. So we have choose near 100 such a way like the pixels above 100 will become 1 and 0. It is manual thresholding, so it won't work for all kind of images. So if you want to do this an automatic, like if you want to allocate an automatic threshold, then you have to go like there are algorithms like Otsu thresholding, like where it allocates the threshold automatically based on the image intensity. So you could also have your own algorithm. Okay. So this is manual thresholding, like 100 based on the image. If, for example, if you give this as 10, let us check the output. The common number of coins is 1. Okay, so it depends upon the, so the output depends upon the correct threshold. If the threshold varies, you'll get the wrong output. 100, you get the coins 10. So what happens? Let us check 150. The threshold value is 150. When I put this threshold value is 150, okay, it shows it's 18 coins. The total number of coins is 18. So you have to choose the threshold properly. Okay, 10. So I will explain the code one more time. Like you have to read the image, allocate a threshold, finalize the image based on threshold, apply median filter. Boundary labeling is used to connect the closed components, and this is to like to segment the coins. Okay, segment the coins. So with this, we have completed thresholding and image segmentation, as well as the count the number of coins in image. Okay, we have completed, and the final experiment is histogram equalization. Okay, I'll explain the code here. You read the image. IM adjust is used to do contrast enhancement based on intensity adjustment. And histogram equalization, this is adaptive histogram equalization. Okay, so C and D. So I'm going to copy this code. We are running out of time, so I'm copying this code, and then just I'm pasting this code here. Save the program as example 10 and run the program. So this is a montage. This will create a montage image. So I'm going to close all the figures which was open in the previous window. Clear, and figure will create a new window. Okay. So this is the image and intensity adjust image. This is a contrast enhancement by adaptive, by histogram equalization distribution. It's an algorithm to distribute the intensity of the pixels, and this is adaptive histogram equalization. Okay. So with this, I close the session. So like we have 30 days internship, AI internship on MATLAB, as well as 30-day internship on MATLAB masterclass. So we will be covering up like the basics of MATLAB image video processing, neural network, and fuzzy logic, neurofuzzy logic, machine learning, deep learning, app development, and guide development. This is the MATLAB masterclass series, which we offer at 750 rupees now. And for AI internship is also 30 days. Like it's the same curriculum will be there. And the project included will be like almost around for MATLAB masterclass it is around 15 projects, and for AI masterclass it's around 10 projects. Okay, so if you want to use the internship, like you'll have a separate portal, and we'll provide you the presentation as well as the source codes and support. If you want to avail the internship, you could avail the internship. And thank you so much for coming, and thank you once again. Meet you in the next session tomorrow. Until then, bye bye.